Hi, my name is Tori Morgan, and I'm a member of the QSDsan group that uses quantitative sustainable design for sanitation and resource recovery systems. In this video, we will cover the layout of QSDsan, what the component class is, how to create a components object, and how to compile components. To start, we're going to go over to the tutorial section and click on the component tutorial. And before you begin, if you haven't already, you should watch the first video that gives a detailed description of QSDsan that you can find right here by clicking on this link. Once you've watched the video, you can open up Jupyter Notebook and we can walk through this tutorial together. If you need any help with setting up QSDsan in Jupyter, you should first check out the tutorial on Helpful Basics, where Yalin can help you set up your Jupyter Notebook and share helpful tips and tricks on using the tools in Jupyter. Once you have watched this video and gone through setting up Jupyter Notebook on your computer, we can begin. Now to start, open a new file wherever you'd like on your Jupyter Notebook. I've named mine Tutorial 2 Components. We will briefly go through the Getting Started section first. You can go ahead and copy the first line of code and paste it into your first cell. You can click Command Enter or Control Enter if you're a Windows user, I believe. And you should see the Unified Modeling Language diagram appear. Today, we're going to go over the most basic class of QSDsan, which is the component class that has attributes like degradability and operations to pull in a chemical. Now, let's import QSDsan. So click B to have a new cell, and then import QSDsan, and as Yellen mentioned, you can import it as anything you would like, as long as you remember it. So you could import it QSDsan as banana, and as long as you use banana every time, you'll be okay. For convenience of this tutorial, I'm just going to do copy what is in line 2 and import QSDsan as QS. And then print. To check what version we are using. Mine should be slightly different than what you'll see on GitHub. Okay, let's see if this works. So Command Enter. The star means that it's running. Okay, yes, so my version is 3.2 and the current version at this time the video is made is 3.3. So now that we've imported QSDsan, let's see how we can make a component. A component can represent a pure chemical such as water or a group of chemicals that are of similar properties like phosphorus accumulating organisms. We can use the code qs.component ? To see more of what this means. And if you're curious as to what is in a class, you can use this line of code to learn more about it. So let's go ahead and do B as in boy, and then type in qs.component ? Command Enter. Awesome, we see that a component has many attributes that are associated with a chemical or a group of chemicals. We will have to define these if we want to make a component from scratch. So for any component, we have to identify these 4 attributes: ID, particle size, degradability, and if it's organic or not. The measured as attribute will affect the units and values of the I attributes. So let's go through this example of creating this phosphate accumulating organism. To do so, we need to type in what we want to name it. So XPAO equals, and then whatever we imported QSDsan as, I did QS, the class, parentheses, now give it an ID, the formula for the chemical or similar chemicals, okay, and then measured as COD, and we'll see in a minute what that will look like. The phase of the chemical. So I'm having liquid, particle size, I'm going to click enter here. And then finally, organic equals true. So remember, really all we needed was the ID, particle size, degradability, and if it's organic or not. But we happen to have more information about this chemical. So now we can click Command Enter, and another line. Now let's see if we did that correctly. So, okay, so this shows you how you can view these chemicals. So we'll want to have the dot show and then have chemical info. The default is false, but we want to look at true for now. So let's do so same thing, XPAO dot show, and then put that format that it requested. So chemical info equals true. Okay. So it looks like we did everything right. We have the ID, its phase, and then it will measure as COD. So for the I components, you'll see that COD now has a measurement and the rest of them are still 0. So great, we did it correctly. Let's move on. Now let's see what happens when we have false. So I'm having a hard time scrolling down on my computer. There we go. Okay, so it shows more description of the phosphate accumulating organism as we described it. So we can use either true or false. True will give a little bit more information about the component, and then false will give us a brief description. So if you want to know what a specific attribute means, you can check the documentation. So for example, for this one, if we're not sure what MW stands for, what this attribute means, we can do .mw ? And then we get the type. So it's a property, and it represents the molecular weight with units of grams per mole. So if you do not provide the correct information, you will likely receive an error for your chemical. So let's see how we can import a component from the chemical class or chemical object. So what if we don't want to create a component from scratch? So instead, you can also convert a chemical object from the Biosyn package to component by providing the information needed. For example, we can take a water chemical and let's name it H2O chem. So H2 capital O underscore chem. And have that equal QS, or whatever you import QSDsan as, chemical. And then the ID for this is H2O. So let's see. And then let's do H2O. Oops. And now we have our chemical, and you can see attributes about this chemical. And these are the default settings from the BioSteam package. If we want to check that we converted the chemical, we can check its type to confirm that. So let's see, type. You have to be very careful. Usually mess up with my O's and zeros. So type H2O chem. Let's see if this works. Yep, thermosteam.chemical.chemical. Then we can provide the extra information that we have to make it more robust. So let's get another line in there, and we can type H2O equals QS.component from chemical, the ID, and I'm just going to go ahead and copy the rest of this. So hopefully that's correct. Let's see. Looks like it works. So we can also pass a search ID to look into the database. So if you want, you can check out the tip. So to do that, for example, for ammonia, we can do SNH4 equals QS. And so the same thing, but you'll notice the difference is I already have the ID right here, and I'm providing a search ID. So the search ID for this is ammonium. Before, I believe it was water or H2O. So we can copy and paste this line into our code. And then it shows that it is in a database. Its phase, what it's measured as. So it's measured as nitrogen. And so you'll see that there's a unit for nitrogen, but not for the other I components. So that's how you can pass a search ID to look into the database and find a component. If you want, you can check out the tips section to see how you can put the values or the keyword arguments in the values and why we might want to do that. And then also why you would want to set the phase of a component. So right here. For now, we will move on to section 2 of the tutorial and look at components objects. So now you can think of components with an S as like a list or collection of components or component objects. This lets QSDsan know what component objects we want to work with in the system. Similar to component, we can create components from scratch by specifying all the component objects. So we can take the phosphate accumulating organism and ammonium and set it equal to our first components. So let me just add some lines of code right here. And you can call it whatever you want. I'm going to use similar as a tutorial. So components1 equals qs.components xpao SNH4. Then let's see. So it's pulled in phosphate accumulating organism and ammonium into our components. All these component objects will be stored as attributes of the component object. We can see what the attribute looks like by typing the component or components and seeing the specific components. So we can do this by putting in components1 dot and that specific component and see that it prints what the component is, what it's measured as, so a COD, and any other information that we might want to take a look at. You can add component objects by appending them one at a time with append. So say now we want to add water into that components. We can do components one.append and type in H2O. And to see if it did it correctly, we'll type in components 1. So now we have phosphate accumulating organism, ammonium, and water into our components. If we want to extend multiple component objects, we wouldn't be able to use this line of code here. So components one.extend, because we can only take one component object at a time, but we can wrap all components and then extend the collection of them like this. So I'm just going to copy and paste methanol and ethanol into the line of code and enter. And then instead of doing components extend, I'm going to create the collection. And then components 1. So let me do. Earlier, we could also create a copy if you wanted to. I'm just going to keep it as components 1. So now we can see if this all worked correctly again. So components 1. Now we have our phosphate accumulating organism, ammonium, water, methanol, and ethanol. We can also pull components from chemicals by using the form or by using from_chemical method of components. So there's a tip right here to help you understand the difference between function and method. But if you wanted to import or pull components from chemical, you can use this line of code right here. So let's see. We already imported QSDsan, so I'm just going to copy this into my line of code. Let's see if that works. So oh, let's try that again. Okay, and then let's see if it printed correctly. So now we've imported water and ethanol from chemicals instead of creating it from scratch. We can also load the common wastewater default components by using this line here. So if you know you're going to be using a lot of the default chemicals and wastewater modeling, you can just simply add this line here. And then components 3 to make sure. And now you have all of your common chemicals and wastewater modeling uploaded. So you can see water was uploaded, methane, nitrogen, and all kinds of chemicals. Finally, we can load components from file. And to do this, you'll want to import pandas, as you see here. You'll want to import data path from QSDsan.utils, and then you can also import OS. And so if you have a TSV file, and I'm pretty sure you need to use TSV and not CSV for this, but you'll convert it to a CSV. So name it whatever file you want. So here it's file path, and then the path to that TSV file, and then create the data frame for the CSV. And then you can print the first few lines to make sure that it correctly loaded those components from a file. And so there were 2 ways to create a component from scratch or from chemical, and then you can also, there are several ways to create components or pull components from chemicals, and you can load default components or components from file. So many options there for you. Next, we're going to talk about how we can compile components. Compiling components can be easily accomplished by using the compile method. When using compile, ThermoSteam will check if all component objects have the properties needed for thermodynamic calculation. So for our components 1, we need to provide more information before we can compile it. We can manually provide the missing data, or we can use the default method and copy some data from H2O with this line of code. So you can see here's the default method here. We can copy this line of code into our notebook, and then we can compile it by doing our components.compile method, and then Command Enter. And so now you see our components have been compiled together. Now that we have all the information, we are able to compile the components. If you use the default method, it is best if you let it compile during loading with the load default. So right here you see load default. And those were all of the default wastewater modeling components. However, when you compile, you can no longer add components or component objects to your compiled components. So if you forgot to add a component before compiling the components, you would have to make a new components containing all the component objects that we compiled. So for example, here, if we wanted, so we had components 1 and we compiled it. If we left something out, we would make a new component. So we have components 4. And then we would want to add with our append that component object. So now we have our phosphate accumulating organism, ammonium, water, methanol, ethanol, and then hydrogen. So another trick is that if you want to work with a subset of the compiled components, you can pick which component IDs that you want into a subgroup, like so here. So if we have certain components from components 3, we can create a subgroup of them and list that in components 5. And so you see the compiled components here from that subgroup. If you want to learn more about why we compile components, you can check out this tip here and the paper behind using libraries like NumPy here. So after we compile components, we can add synonyms of those components. So for example, you might want to use water instead of H2O. So then what you can do is you can set synonym so that it recognizes that water and H2O are synonyms of each other. Just gonna enter, and then components 1.h2o.id. And so that should come up as H2O still. And we have H2O. And so now to see if this works, for the synonyms, we can do the same thing with water and it should have the same ID. The ID does not change. So let's see. H2O. So both of them are now synonyms of each other with the same ID. Finally, it's important to note that in Python, being the same object is much stricter. Just because you copy a component does not mean that that copy is necessarily the same as you can see with this example here with lists. The components and its copy will have different IDs. So that's the end of this tutorial, and I hope you found it helpful. I'm not an expert at coding, but I find QSDsan to be very user-friendly, and these tutorials have strengthened my computer programming skills, not just for QSDsan, but for other projects I've been working on. So I would really take advantage of going through these tutorials and getting more familiar with the documentation and QSDsan. In our next tutorial, we'll go over what a waste stream is.